Some guys, I think is it Martin who was saying this guy is behind. I could have decided to ignore about revising this test, but you performed dismal. So I don't know. Probably you got 20 out of 20, Martin, right? Can we assume so? It's a very short test, but most people, some they even got 2, some they even got 0. So that's why I'm taking this time to assist you on this concept. I could have been chilling. So let's look at this test. It was a very easy test if you are following the lectures during the semester. So this is an output from SPSS. So the output from SPSS, it has got the ANOVA table. It has got the multiple linear regression, all right? So the predictors, they're also called, these are also called independent variables that you know, and also call them explanatory variables in some field. In some field, they call them covariates. So it's either predictors, covariates, explanatory variables, independent variables. So we have got the constant, which is the intercept, and we've got x2 and x1. Then we've got our dependent variable being what? Being y. So that means since you've got more than one independent variable, that means this is a multiple linear regression, since that's what you have learned. So the first question says, write down the equation of the fitted line. So what's key is for you to be able to pick the parameters from the output to say what is this, what is that, what is this, right? So the question that I will relate to you, we need to know, since this is a multiple linear regression model, it's y is equals to beta naught plus beta 1 x1 plus beta 2 x2, right? So the question is, what is our beta naught? What is our beta 1? What is our beta what? Our beta 2. So you come up with your contributions. What is our beta naught? You can participate, guys.
0.036.
0.036, that's our beta naught, right? And then what is our beta 1? Beta 1, remember, is the coefficient of x1, right?
0.934.
So what is beta 1?
0.934.
0.934, excellent. So that's it. And then what about for beta 2, which is the coefficient of x2?
1.031.
1.031, right? So now we can come up with our model from what we have said, that y is equals to beta naught plus beta 1 x1 plus beta 2 x2, right? So in this case, we are saying y is equals to 0.036 plus 0.934 x1 plus 1.031 x2. So just writing that model, you get 3 marks. So you should be able to pick which are these, in the first column, this one, with which are our parameters for the regression model. So you need to be excellent on picking up. The next question says, state the null and alternate hypothesis, clearly test the significance of the regression line. The question is, when we're testing for people they didn't understand, some of the people they didn't understand what this question required them to do. It says test the null hypothesis and alternate hypothesis, clearly testing the significance of the regression line. So when you're testing for the significance of the regression line, what do you use? Let me hear from you. What do you use?
When we are testing for significance of the regression line, it's more like we want to test that the coefficients for x1 and x2 are 0. So we use the coefficients for x1 and x2, which is beta 1 and beta 2. We want to test if beta 1 and beta 2 are 0 or not.
So which approach do we use then? It's okay, but which approach to use? Are we going to look at them separately, like looking at the p-values for each coefficient, or we've got another approach that you should use when you're testing the significance of the regression line? Hello, guys. My question is, what should we use? She has explained that we are testing whether beta 1, beta 2, it's not equal to 0 or it's equal to 0. What should we use then to test that?
I think we use Pearson's test.
Hello. Why do you use it? Why Pearson? Remember, Pearson measures the intensity and the strength of the relationship of two variables, right? So what should you use? You guys, you know how to calculate these things, but now we are asked in a simpler way. Okay, which conclusion do you come up with? I think there's a conclusion that you usually say, therefore the linear regression model is statistically significant, or the regression line is significant. Which conclusion will you be coming for? There's a conclusion that you, in your assignments, you're writing the linear regression line is significant. What will you pay for me?
I think beta naught.
No. Who is it? Is it Millicent?
No, Lisabel.
Lisabel, you did assignment 1, right?
Yes.
You did assignment 2, right?
Yes.
Do you have them by next to you?
What?
Do you have them next to you?
Let me check.
So are you telling me, 18 guys, you don't understand when you're saying let's test the significance of the regression line? What are we using?
Say, isn't it the gradient?
I think there's somebody who said we are testing beta 1 and beta 2, which is correct. My question was, which output are we using? Are we using the ANOVA or we are using these p-values? If you're testing for beta 1 and beta 2 at the same time.
I think we use the ANOVA table, the significance value on the ANOVA table.
Yes, that's it. So I wanted to understand whether you understand this question to say, when we test the significance of the regression line, we are testing the completeness of the model, right? We are not testing them as separate. So that's why somebody was saying we test whether beta 1, beta 2 is equals to 0 or not. Excellent. Now let's state the hypothesis now. Can somebody give me the null hypothesis? Guys, don't come to this and expect me to give you answers. I'm not giving you answers. You bring your ideas and then I correct them.
The null hypothesis is
Okay, go ahead. Whosoever starts. I think there's the two ladies. Who is that? Yeah, Millicent, you can go ahead.
okay. The null hypothesis is beta 1 is equal to beta 2, which is equal to 0.
And then the alternate.
I'm not sure on the alternative hypothesis, but I think maybe beta 1, beta I is not equal to beta J for at least one I.
So which is beta I is not equal to it's not equal to 0, right? For at least one I. And then what's the rejection criteria? So in this case, guys, if you're given an output, right, we are not going to use this F. We're not going to use T. We're not going to use all that. F and T. We're not going to use F and T. So why do we use? We will use the significance. Significance, which is the last column. Why did you use this F and this T? We're saying if you know how to use this F, you know how to use this T. But all we're saying is this is more of academic approach, right? So that you can understand the concept. But beyond that, right, when I give an output, Spss output, expecting you to use what is used working, right? So what's the rejection criteria if we're using the p-value? Can you what guys are listening to me?
This is Gonzalez.
The rejection The rejection criteria for the
We reject H naught if P is less than our given alpha. In this case, our alpha is 0.05.
excellent. So no matter in which situation, that rejection criteria will never change. All right. So I need somebody else to give us the conclusions. Our p-value in the ANOVA table is 0.000, right? So what's the decision and then what's the conclusion? Brandon. Okay, whoever wants to say, you can go ahead.
Since our p-value is less than alpha, which is 0.05, we reject H naught and conclude that there is no sufficient evidence to say that the module is insignificant.
Perfect. It's okay. Excellent. Next, coefficient of determination. What's the formula for coefficient of determination? What's the formula for coefficient of determination?
It's SSR over SST, or 1 minus SSE over SST.
It's SS what R over SST, right? Multiplied by 100.
Oh, yeah, multiplied by 100.
So what is our SSR here? What's our SSR? Pane munhu akangonyarara chaiwo achitadza kuti achitumira kuti munhu ataura.
0.025.
Iwe uri kuti why didn't you say the answer? Who said
I think 57,133.
Yes. I wonder somebody who would say why didn't you say the answer? Next time, if I teach you a similar course like this, when you are doing Zoom, if you say it's better you be removed from this Zoom because you seem like you don't want to contribute. You are waiting to check on somebody's answer. Be careful on that one. So SSR, it's 57.1333. Right, that's SS regression, right? This one, the residual, right? It might be called the error or is called what? Residual. Then what is our SST?
57,159.
Yes, excellent. So you say 57.133 divided by 57.159 multiplied by 100. What do we get?
99.95.
99.15, right? Excellent.
95.
But now, okay, people, they're confusing. Most guys were confusing. They were mixing up with coefficient of variation. This is coefficient of determination. So what's the formula for coefficient of variation? Anyone know? If you don't know it, go and check on the notes. So it's 99 point what, Lin?
99.95 or 96. Yeah, 99.96.
So can you interpret? Can you get somebody who interprets the coefficient of determination? There are two approaches that you can use to interpret the coefficient of determination. What's the first? One can say in approach first.
I think it means this model is 99.96% the variability of data.
Yeah, that's almost there. All right. There's some element of correctness, but we need to perfect it, right? So based on that comment that you have said, can somebody help him?
I think maybe we can say we can say 96.96% of the variability is explained by the regression line.
Yeah, almost there. Almost there. If you're saying we're saying you've got 99.5%, right? Accounted by the model or accounted by the dependent variable. All right, so you're saying the 99.5% is accounted by y, right, which is explained by the variation in what? In the independent variable, that is x1 and what? And x2. Let me repeat again. 99.5% is accounted by the regression model. In brackets, we're saying that's the dependent variable, which is explained by the variation in what? In independent variable. In brackets, that's what? X1 and x2. So I said 99.5% is accounted by the model, in brackets, that's the dependent variable. I'm saying 99.5% is accounted by the regression model, right? In brackets, we're saying that's the dependent variable, which is explained by variation in what? In independent variables. That's x1 and what? And x2.
Sorry, you said x1 and x2 are dependent or independent variables. I didn't get that.
Independent variables.
Okay.
I said 99.5% is accounted by the regression model, right? Which explains the variation or the variability from what? From the independent variables, that is x1 and what? And x2. Is it clear? Hello?
Hello.
Is it clear, the interpretation that I gave?
Yes.
Yes.
What is another interpretation? Hello, what's the other comment that you can?
I think maybe we can say like maybe we can define coefficient of determination as like the percentage of data that is closest to the line of best fit So in this case, maybe we can say 99%, 99.96% of the data is close to the line of best fit, which is the regression model. So our model is like useful or something.
Yeah, yeah. Our model is good. Our model is really useful. Absolutely.
Or
Absolutely.
say we can say 96.95 indicating the adequacy of the model.
Excellent, excellent. That's perfect.
Okay.
The adequacy is good. The model is useful. The model is good, right? That's another way of interpreting. And then the last question: calculate the 95% confidence interval for the intercept of the line and test the significance. Test the hypothesis H naught beta 0 is what? That beta 0 is not equal to that. So what's the formula for the confidence interval, guys, for intercept? What's the formula for the confidence interval for the intercept?
The formula is, the intercept is beta naught rate. So it's beta naught head plus or minus T n minus P at alpha over 2 multiplied by the standard error of the beta naught, the intercept.
Okay, suppose you're doing it manually, Millicent. What's the standard error of beta naught?
The standard error of beta naught is S squared. It's root of S squared open bracket 1 over n plus x bar squared over SXX, all in bracket squared except for the S squared.
I think S squared will be also in the brackets. Don't you think so? Hello?
Hello.
S squared should be inside the bracket, the square root sign.
Yeah,
but it's not inside.
Yeah.
It's not inside the brackets, but it's inside in the square root sign.
Yes.
Right. So you need to know the formula that you use when you're doing it manually and when you're doing what? Using the output from the SPSS, right? So usually it's given on the output of a software, but in this case, I decided to remove that. Right. So in this case, what do we need? We need beta naught, right? And then we've identified our beta naught. So you're now saying plus or minus T n minus P. So the question is, how can you get your n? I think people they faced a challenge how we could get our n there, right? Our parameters, we know that how many parameters do you estimate? There are 3, right? And what's the standard error that corresponds to what? To beta naught? Because you have said you have to multiply Tn minus P with the standard error of beta naught, right? So what is the standard error? So what was key on this question was for you to be able to identify the standard error, and also you should be able to identify n. So we know our beta naught, right? That we have mentioned initially, that's 0.036, right? But what is our n, and what is the standard error of the beta naught?
I think with it one in, we add 1 on the degrees of freedom per SST. So our n is 9 plus 1, which is 10. Then our standard error for beta naught is 0.052.
Excellent. So we are saying to remember our formula for getting the degrees of freedom, right? For total, right? If you know the formula, it's n minus 1, right? So n minus 1 is equals to 9, right? And then you make n the subject of the formula there. So you get n is equals what? To 10. That's excellent. That's correct, right? And then the standard error for the beta naught is this value, which is 0.052. Right. So now I think let me give you time to calculate as we join the meeting again. So calculate the confidence interval, guys. Now we've got everything. So let's calculate the confidence interval. Let's calculate the confidence interval. So I'll give you 5 minutes to complete that.